Hi. Well, there's Matthew. Right, I'll just do a quick intro, Matthew. Just 1 second. Final presentation before lunch. Very, very important. The previous assets management. We did have an input last year about decommissioning, but this is different. One thing I've said is that if we had a very good case study, I think they're good, which I know Matthew's going to focus on amongst other things. And also, I think our sector sometimes can be a bit internal and not getting the best learning. If the previous examples had some really good learning that are not necessarily from the process sector, but can be applied to the process sector. We need to get away from the not invented here syndrome. So I'm sure this will be really good from one of the leading authorities really in decommissioning and demolition and remediation and all of those things, because we put them all together in one big thing. It's not like it used to be, as we all know. So, okay, Matthew, I'll come out and I'll see you at the end. Enjoy.
Thank you, Felix. I hope everybody can hear me okay. Again, thanks to Felix and NEPIC team for the invite to speak to you all this afternoon. And the theme of the day, asset management, and the focus of our presentation and what RVA do is asset management and particularly associated with end-of-life asset management. So I'm going to share my presentation now. I have prepared, so hopefully you will all see some slides come on screen. Okay, I believe that you can all see the slides now, so I will make a start. Yes. So, practical examples, decommissioning, power sector, transferable lessons to process sector. I was asked to discuss and compare the typical decommissioning activities versus a power station, a power generation plant, and a typical process chemical plant. What can be learned, what can be shared, what can be improved upon, and using the experience that we RVA have in carrying out the projects that we carry out in both sectors. What you can see on the screen there, the two photographs. One is a power station, a 2,000 megawatt coal-fired power station, which RVA worked upon throughout the decommissioning phase, right through when the plant was operating, designing the decommissioning activities, working with the client team to understand what needed to be done, how it needed to be done, and when it needed to be done. And to the right is a process chemical plant. It's an unnamed asset. I can't give you the details of it, but it's in the northwest of the UK. Some of you might be able to do the mental arithmetic. Anyway, before I do that, let me just give you a little about me and about RVA Group. So first of all, me, and most importantly, I am Matthew Waller, Operations Director for RVA. But more importantly than that, I'm dad to two very excited young children. Already can't sleep, so goodness only knows what the next 2 weeks before Father Christmas arrives is going to bring for us. Football fan, motorsport fan. So if nothing else, over lunch or a cup of coffee, we can chew the cud about the latest happenings in Formula One or with Middlesbrough Football Club. In terms of RVA and my profession, well, I'm a mechanical engineer by profession, and I've got my real passion, my real driver is associated with driving safety, health, environmental performance, zero harm principles, basically, and using expertise in project management to ensure that those things are at the top, the non-negotiable drivers of every project that I'm involved in and that RVA is involved in. In terms of RVA, we were formed in '92 with over 800 high hazard DDD, decommissioning, dismantle and demolition projects. We take on the legal duty holder role of the CDM principal designer and designer. We're completely independent from the supply chain. And we're 9,000, 14,000, 45,001. I think, key question about RVA is why? Why do we exist? Well, we recognise that there is a gap between the expertise of the owners and operators of these high hazard process sector power generation plants, and the gap is to where the demolition contractor is, and in the demolition contractor specialist skill set though it may be, there is a gap between the knowledge and understanding of the two various disciplines. And we aim to fill that gap. We aim to provide the information between client and contractor to be able to ensure that that project is pushed forward with that safe, zero harm principle right at the top of the agenda with a non-negotiable basis. In terms of who we work for, these are a small selection of the types of clients, and I'm sure you'll recognise some of them, worldwide, multinationals, Teesside based, and also wider across the UK, Europe and elsewhere. So I'm sure you'll recognise some of these names, and feel free to talk to me about any of the names and the projects that are on here. Before I go any further, I'd just like to, first of all, check the message board and check that people aren't saying, I can't hear you. No, everything sounds good from the message board. I think, what is decommissioning, or specifically, what am I talking about here? Because what's important to note is the word decommissioning is used regularly. It's used in the process operational sector when a part of a plant is taken out of service. It's used by the demolition sector. It's used by many people for many different things. In terms of what I'm talking about today, it's associated with the preparation of a plant, whether that's a power generation or a process sector plant, for dismantling and demolition. Really important here, I'm not particularly talking right now about exactly the safe means of cleaning a particular vessel or isolating a particular piece of equipment. And I really must stress that the safe systems of work and the management of change procedures, they must be thought about and adhered to. But what I am going to talk about is, what we're aiming to achieve. And also, really important to point out that decommissioning is not mothballing. Mothballing is different from decommissioning in terms of preparing a plant for dismantling and demolition. What decommissioning covers when you are preparing a plant for dismantling and demolition, it covers the decontamination, taking it from a status of being contaminated to decontaminated. It covers isolation and physical disconnection, ensuring that the sources of energy have been identified and either removed or clearly highlighted. And it covers some other plant preparation activities, and I'll talk about how these tie into each other as we go on. And ultimately, what we're looking for is the known condition, so that the project can move forward into its next life cycle. In terms of the why do we carry out decommissioning? Well, the two photographs on screen show you some of the activities which would be carried out on your plant, whether it is the hot working and the obvious hazard that brings to process sector and power generation plants, or whether it is machine demolition, where specialist demolition machinery will carry out the removal section by section and dismantling of plants. So why do we decommission? The key thing is British Standard 6187, the Code of Practice for demolition, that specifically details that you need to decommission. Your EPR license, your Environmental Protection Regulations license, will require you to prepare a decommissioning plan. But ultimately, the real big driver for companies such as those that we work with is because you need to ensure EHS and regulatory compliance. You do not want to hurt people, you do not want to hurt the environment, and you want to ensure that you have the full, absolute assurance of regulatory compliance. The consequences of not getting your decommissioning right are that non-negotiable driver, which I talked about very early on in the presentation. That non-negotiable driver of zero harm principles can come under attack. So your key principles of decommissioning projects is EHS and regulatory compliance, its value, its program. And you've got to recognise that the EHS performance of any decommissioning project is directly proportional to the knowledge, the experience and the skill set of those people involved. And that is where the three areas of client, demolition contractor and specialists have to come together and mesh. And in the example that I mentioned earlier and on the compare and comparison stage, I identified the 2,000 megawatt coal-fired power station, which we were involved in preparing and executing the decommissioning activities on. The client there recognised that they didn't have the full skill set, the full understanding. They identified this gap between themselves and the ultimate customer at the end of their decommissioning project of the demolition contractor. They recognised that there was this gap, and they brought in the specialist RVA. They brought in the specialist to help fill that gap. And one of the things that was a real success in that project was that RVA were brought in while the plant was still operating. And while the plant was still operating, a small team within the client's organisation, assisted and aided with RVA, started to build up the decommissioning plan. And that decommissioning plan, the fine detail of it, was built up over a number of months prior to the power station actually shutting down. And what that meant was that RVA could help to understand and learn and understand the client's plant. Nobody will understand and know the operation of that plant better than the client, the owner-operator. RVA are there to help bridge the gap to the demolition contractor. So we could understand what the client was doing. We could also help the client understand what the demolition contractor would be doing, what type of methods would be used, where the demolition contractor would start, how the demolition contractor would go about it. And so we helped design the decommissioning activities with that client for that power station, so that all of those three items which I mentioned previously, the EHS and regulatory compliance, the value in the program, could be taken into account as it was designed. I touched on previously known condition. I think it's really important to talk about known condition. It sounds really simple, a state where all of the hazards are known. But that is a really critically important aspect of doing it. It is not the removal of all hazards. It's understanding what contamination hazards there are, what contamination hazards are to be tackled at which stage of the project. It's understanding what the live service hazards are, what live service hazards are to be tackled at which stage of the project. And it's understanding what the stored energy hazards are and how they are to be handled at different stages of the project. Materials of construction, another important point. And as I said there, it is not the removal of all hazards. This known condition is really important, and the identification of that known condition right at the start of the project is really important. Going back to the power station I mentioned, one of the very first things that we did was sit down with the client and understand what their systems actually were. What systems are actually on this power station? What is the known condition? And from that, we started to develop decommissioning strategies. So what are decommissioning strategies? I mentioned before, decommissioning, when you're preparing for demolition, sort of covers three aspects. It covers the decontamination, it covers the plant preparation, it covers the isolation and physical disconnection. And these three things come together, and some items are purely decontamination. Some items are purely isolation, physical disconnection. Some items are plant preparation, and some items cover all three. And some examples for you. You see in the top left of the screen a hydraulic system with a number of hydraulic packs and the associated accumulators. Those systems, they need plant preparation, they need the stored energy removing, they need some decontamination, and they need isolation and physical disconnection. You see a sulfuric acid reactor to the top right of the screen, and you see this reactor in particular was lined, and one of the problems with the reactor is that the lining would fail, and sulfuric acid sludges would end up in behind the lining. And that needed a specific decommissioning strategy for it. To the bottom right, we have a reactor with a toxic catalyst, and that needed a specific decommissioning strategy. And to the bottom left, it is the isolation and physical disconnection. That was purely isolation and physical disconnection. So for every system, we would identify what the strategy would be. And as part of that, we use a really quite an engineering and risk-based approach to say, what is the strategy for this specific system? And that strategy has got to be a function of the hazard and the skill set. And so, taking an example from the power generation sector, we looked at a heavy fuel oil system. We looked at the heavy fuel oil system, which was a backup and low power fuel firing system. And we said, what is the hazard associated with this material, heavy fuel oil? I'm sure most people know and understand. What is the skill set that needs to be carried out? And we looked at this heavy fuel oil system, and we defined a decommissioning strategy which was different at different parts and different points through the system, from bulk storage through to transfer through to direct front of the boiler. At different parts of the system, we had a different decommissioning strategy. And that different decommissioning strategy was based upon who the best people were to carry out those activities. And that is shown in this simple schematic. What is the system? What are the material hazards? How is it going to hurt people? How is it going to hurt the environment? What skill set is needed? What skill set is required? Where does the expertise lie? In some systems, in some functions, the most appropriate expertise is to carry out the decommissioning using the owner-operator of the asset, the owner-operator of the system and procedure, so that the skill set is known because the hazard is so high. In some functions, in some systems, the skill set could be carried out by a contractor. What activities are needed? What are the activities required, and when are they to be carried out? We also need to talk about how clean is clean. What is the cleanliness that is required? What is the cleanliness that needs to be carried out? You see there, and in terms of the scrap metal chain, you see where the end point is. You see an intermediate point. When you speak to many waste receivers, scrap metal waste receivers, they will identify that some of the most hazardous materials that they handle are end-of-life vehicles. You start to define your decontamination processes, identifying the systems, again, using this hazard-based functional approach. What are the hazards? Have a hazard study process. What are the inputs that are needed? What are the activities that need to be done? Have a clear process, ultimately move into ending up with documentation, which identifies that known condition and output to the demolition contractor. When we talk about isolation and physical disconnection activities, this here is associated with ensuring that all supplies of power sources of any means are isolated and physically disconnected, or clearly identified to the person who's coming along at the end, the demolition contractor. One area here where power station decommissioning, is very clear and sometimes can be very simple, is a complete red ring of a whole site, rather than going to each individual drive, individual motor, individual power source and isolating hundreds or thousands upon thousands of cables, isolating and disconnecting thousands of cables, going to the power source of that particular plant, that particular site, that particular location, and carrying out a small number of cable cutting activities, of isolation and disconnection activities, before you then go and carry out a downstream testing of that. But what it would do is minimise the risk associated with the execution of those activities. In terms of plant preparation, it's application of exactly the same thing again. What is the system? What are the skill sets? What are the activities? And what are the plant preparation activities? Electrical energy, battery packs, rotating equipment, large rotating equipment with the potential to move under its own power, lifts, stored energy in springs, accumulators? How do you decontaminate labs? What do you do with transformers, gearboxes, radioactive sources? A key thing to think about, understand, is your documentation. At some point during your decommissioning process or towards the end of your decommissioning project, you will undoubtedly lose expertise, experience, knowledge and understanding in the activities that have been carried out and in the plant which has been decommissioned. You need to make sure that you have detailed decommissioning records, individual records per item and equipment, area and system records, and ultimately handover reports. And as you can see, there is an increasing level of detail as you go down, but you make sure that you're able to summarise succinctly to a demolition contractor what that handover report looks like and what that ultimate known condition is. So I know people are hungry, so I will focus on the learning. And I'll explain that the most important thing to do is at the start of your decommissioning project, before if possible, the plant has stopped producing, start with this hazard-based approach, identifying your strategy per system. As we did in the power station, we sat down with the power station operators and we listed systems, and we listed system upon system. The charts that Chris had on the wall for his lean discussion, were very similar, but we had lists on the wall of systems, and we ultimately combined them into a whole system and whole system list. And we went through system by system using this function of hazard and skill set. Absolutely must consider the customer of the decommissioning. Make sure you understand who is going to be doing this and understand the demolition contractor or the dismantling contractor's skill set. Be open to challenging the normal preparations practice. In some instances, we've found in the process sector where plant teams, maintenance teams, shutdown teams are used to carrying out shutdown turnaround activities, and they have a whole load of normal preps, systems and procedures. Those normal prep systems and procedures are not always suitable to dismantling demolition projects. And you need to be open to challenge those preps practice. It's not to throw away everything that has been done. It's just to be open to recognise that the decommissioning, dismantling, demolition project is different from a turnaround, shutdown, restart project. And finally, it's documentation. Ensuring that you have a robust documentation methodology so that the very succinct handover report can be prepared and issued to the demolition contractor. But from that handover report, you can drill down into the fine detail of where specific parts of the plant, how they were decommissioned, who decommissioned them, and what they were decommissioned by. Right, that's my presentation. I apologise if I feel like I rushed the final half a dozen slides or so, but I wanted to make sure everybody could get away for lunch. I know that Felix has already mentioned the questions towards the end of the day, and I will stop sharing and come back to the screen.
Yeah. Right. Thank you very much indeed, Matthew. Excellent presentation. Just coming up to lunch. If you have any questions of Matthew, he's going to be around. Q&A later. Thank you very much, everybody. We'll be starting again with the presentations at 1:30. New theme, which is all about, I know we had a digitalization conference in September, but these are all new inputs and they're all specifically related to asset management, whereas the conference was everything, all aspects of improvement. So we've got 4 excellent presentations, which are all complementary. I'm sure you'll enjoy them starting at 1:30. If you can, please take the opportunity, obviously, to have a lunch break and a cup of tea, or if that's what your tipple is, or coffee, whatever. But please take the opportunity to talk to our exhibitors. We don't have many on. This is deliberate, but we have sort of 7 really good exhibitors who are all related to asset management improvement. If some of the topics that you looked at today, if you want to know how to do things better, talk to those guys. They're all experts in their field, so please do that. And I look forward to seeing you all at 1:30. And once again, Matthew, thank you. Bye.
Thanks everyone. Take care.